Hi friends, welcome to this session on bubble sort algorithm. Here we will try to understand the intuition, inner workings of the algorithm, and we will see it in implementation as well. So let's proceed with the discussion. So bubble sort algorithm. What happens here is we are provided an unsorted array as we can see, and we have the indexes of this particular array mentioned here as from 0 to 4. We have the 5 elements in this particular array and it is a zero based index. So what happens in this algorithm at we basically first of all iterate through this entire list, and in every iteration we basically compare the two adjacent elements. So in this particular case, we are at 0th position. We are starting at so we are at the 0th position, and we'll compare the 0th position element to the element which is at the first position. And similarly, we keep on moving the pointers in this particular fashion. The next will be our iteration for the first element, and then the iteration for the second element. Third will be the third element and the fourth element. Similarly, the fourth element and the fifth element. So this is one set of iteration that we do. And then again, we will do the second set of iteration when we will start again, and we will go through this particular list again, and we do it till we basically do it for all the elements which are there in the list. So the idea behind this is, let's say if the first element would have been the largest one, let's say it would have been 60, and let's say rest all of those elements would already be in the sorted position. For example, 10, 20, 30, 40, 50, but the first position element is not sorted. So what happens is we compare this element across each of those elements. So if 60 greater than 10, this is with the first comparison, then we will have 60 greater than 20, second comparison, third comparison greater than 30, fourth comparison greater than 40, fifth comparison greater than 50, and at the end, we would have moved the 60th element to the end of the array, and rest of the elements would have been in its position itself. So the idea is, if the first element, the greatest element is coming at the first position, then we are able to get that particular element at the deemed position in the array, comparing it across all the elements which are there in the array. All right. So let's start afresh now. This was just an intuition to let you know that okay, how the thought process behind this particular algorithm would have gone in, wherein we are comparing the one of the element to each of the other elements of the array. So now let's take up the first iteration. So in the first iteration, what we are going to do is we are going to compare the 0th element to the first element. So we will say 20 and we have 30. So we ask the question whether 20 is greater than 30 or not. And the answer comes no, it is not greater than. So we will keep the positions as it is. That is, at the 0th element, we still have, at the 0th position, we still have 20, and at the first position we still have 30. Okay, so now 0 and 1. So now we move further and we take, in the second iteration, we take the element at the first position and the element at the second position. At the second position we have 50. So now we ask the question, when, like, we have two numbers here, 30 and 50. Now we ask the question if 30 is greater than 50 or not. So answer comes no, it is not. So we'll keep this position as it is again. That is, we are not swapping the numbers. So this position is retained, and we now have the another number which is 40. So we are 1, 2, 3. So now in the third iteration, we will take up the number which is at position 2 and the number which is at position 3, and we compare 50 and 40. So we ask the question, is 50 greater than 40? The answer comes, oh my bad, yes, the answer comes, it is indeed 50 is greater than 40. Yes, then what we do is we swap the element which is at the second position, which is 50, with the element which is at the third position. So now the list becomes, after swapping, we get the list as 20, 30, 40, 50. So now we have the indexes as it is. So now we compare In the fourth iteration, what we do, we compare the element at the third position and the element at the fourth position. At the fourth position, we have, or basically at the fifth position, we have, it is the index 3 and the index 4. At the fifth position, we have the element 10. So now we say, is 50, so we have two elements, 50 and 10. We ask the question, is 50 greater than 10? The answer comes yes. So we swap and we get a newer list, which gives us 20, 30, 40. And here we have swapped it. So 10 comes here and 50 comes here. So now we are at the end of the end index, right? We don't have any number over here. So basically we have finished our first set of iterations. And in bubble sort, what happens is after an end of one set of iteration, this is the end of the entire one set of iteration, we will have moved one element to its right position. So 50 is at its right position. So the biggest element, the largest element, moves to the right position, right? Position, right? So now we get in every iteration the remaining largest number move to its right position. So here we got 50 at its right position. Now let's see the second set of iteration. So in the second set of iteration, what would happen is, let's do it here. So we have got this particular list here, right, wherein we have the 50 is at its right position, and we have 10 over here, we have 40, and we have 30, and we have 20, right? So now let's begin with the second set of iterations. So we have, now what will happen is, so we'll start from the fresh. So we will compare the two elements 20 and 30, and we will ask the question whether 20 is greater than 30 or not. The answer comes no. So we will not swap, we will move further. So now we have the element at the first position, or at the first index, and the element at the second index. We will compare these two, 30 and 40. Is 30 greater than 40? No, will not swap, we'll move further. And then we have the element at the third index, yeah, at the second index, and the element at the third index. So we have the numbers 40 and 10. We ask the question, is 40 greater than 10? Here comes the answer, yes it is. So we will swap 40 and 10, and the new list would become like 20, 30. Now here will be 10, here will be 40 and 50. So the largest remaining number was 40 in this list, right? Now at the end of this second set of iterations, we are able to bring 40 right to its right position, right? Because after this comparison, it lasts for the 40th and the 50th comparison, and we get the answer no, because the largest number, which was 50, which was already provided to its right position. So here we get the number 40 at its right position. And here we also see that, okay, since every iteration we are able to bring the remaining largest number to its right position. So it always makes sense that, okay, in every incremental set of iteration, we only check it till the point where the previous iteration has ended. So for example, here in the first iteration, the first iteration, we brought 50 to its right position, right? So the largest number, so the last element would be always sorted after the first iteration. After the second iteration, the second largest number would be sorted at its right position. After the end of third iteration, the third largest number would be sorted to its right position. So it always makes sense that, okay, at the beginning of that particular set of iteration, whether it is second or third, we only compare it to n minus the number of iteration it is, because we already have those. At the end of first iteration, we have got this particular set sorted out, so we only need to compare within this particular array. At the end of second iteration, we have got these two sorted out, so we need to make a comparison only within the remaining part of the array. So that is where we will do the implementation in the algorithm, and this concept will be made use of at that point in time. All right, so this was the intuition about the bubble sort algorithm. which compares the two adjacent elements at every set of iteration and basically brings out the one or the largest element in every set of iteration to its right position. And that is how the name bubble sort came in, because like a bubble, the it comes to the surface. Similarly, in this array, the bubble or the largest remaining element basically comes down to its surface, sort of. So this is kind of an intuition as to how it was named as the bubble sort. All right, so over to implementation and the flowchart. So we understood about the bubble sort. The bubble sort is the simplest of the sorting algorithms that works by swapping the adjacent elements if they're not in the sorted order. Now, point to ponder over here is the time complexity of the bubble sort is big O n square, and both the average and the worst case time complexity is high, and hence it is not suited for the large data sets. This is a flowchart as to how the bubble sort algorithm is implemented. So we have as an input the unsorted array. We find out the length of that particular array, and we do that iteration till we have, and now we set a value I, which starts from 0, that is the start index, and goes till n minus 1, that is, it is less than the length of the array, because the index is 0 based index and index length minus 1 is the end index. We'll go till n minus 1, and this I counter denotes the set of iterations that we'll be doing. The one set of iteration that we saw in the different set of iterations that we saw in the node session sometime back. So now if it checks whether j is greater than equal to 0 and j is less than n minus I minus 1. So now herein the inner loop is coming in. So in every set of iteration, we did some iterations, right? And therein we saw that okay, at the end of every iteration set, the last element or the largest remaining element was brought to its right position. So we basically minus the set of iteration we are on. So if we are at the second iteration, then we will second iteration set. So then we will basically, we know that, okay, the previous iteration set, which was iteration set to 1, there would have been already the largest number at its right position. So we need not to compare the last element in that particular case. So therefore we do n minus I minus 1 and we proceed further. Now here we check whether the two adjacent elements, those are how they compare to each other. If the previous element is greater than the later, then we basically swap it out and we do it till we complete this iteration set. So this is a simple bubble sort algorithm in flowchart. Let's see how it is implemented over here. So here's the implementation of bubble sort algorithm, and the link to this particular GitHub file is there in the video description. And so this is how we get started. So we are defining a function bubble sort IMPL, and we're taking an input as an unsorted array. And we have a variable was underscore swap is equal to false that we have initialized, and we have got the length of the array. This particular variable is also used for making an additional optimization, wherein, as we did the observation, that if we basically go through this array in one iteration set and we do not make any swap, that is, if you are comparing every two adjacent elements of an array and those are already in order, we are not making a swap, that means those are already in order. So what does that mean? That the array is already sorted, right? The moment we get to know within the iteration set, in the iteration set, that okay, at the end of the iteration set, we get to know that okay, no swapping was done in this particular iteration set. Then what we are going to do is we will exit out of the loop and we will declare the array as sorted. No need to go in through the additional iteration sets, right? So that is the main purpose of using this variable for optimization. This adds for additional optimization. Now for I in range n, so herein we are going into this is what it is denoting the iteration sets that we need to do. And the inner for loop basically denotes the iteration across the array that we need to do within every iteration set. And herein we go in till n minus I minus 1, because at the end of every iteration set, so for an example, if we have already done the first iteration set, so we know that okay, n minus 1 elements are the ones which are remaining. The last element has already been sorted out, right? Therefore, we basically minus the number of iteration sets that we have done already, and we basically do not want to compare the, or do not want to go until the last element, because in every iteration what we are doing is we are comparing the element at that current index and the element which is in the next index. So once you reach the penultimate index, you are already making a comparison with the last index, right? So we need not to take the counter within that iteration till the last index. We can stop it at the penultimate index, because at the penultimate index itself, the last element would have already been compared. That is where we are doing it till only till n minus I minus 1. Now what we do is we basically just check it out if those elements, that just elements, how do they compare to each other. If x of j is greater than x of j plus 1, then we need to swap those values. And we also reset the flag of was swapped is equal to true. So that is where we will check here. If the was swapped flag was false, then we are going to break it out. Because if there was no swapping done in that iteration set, then we are basically in this iteration, within this iteration set, after this particular iteration of a particular set has been done, we check if the flag is false, there is no swapping has been done, and we break out of it. Because the list is already sorted, therefore the swapping would not have been done. So this is how the sample implementation of the bubble sort algorithm is there, and we run it against the different use cases, and we see for each of those use cases run, that is how the algorithm has progressed. For an example, if we take this particular example of input wherein we have 10, 20, 40, and then 30, and then 50, 60, and 70. So we see that okay, these three elements are already sorted. We only need to swap these two elements, right? And these two are also position. So bubble sort happens to go like this. So in the outer loop 0, that is the iteration set counter. It makes the comparison is 10 greater than 20, right? Is 10 greater than 20. It says no. Is 20 greater than 40? No. 40 greater than 30? Yes. If it is greater, then make the swap. So it does the swapping, and then now the list becomes 10, 20, 30, 40, 50, 60, 70, right? So this goes in now, the goes further for 40 and 50 comparison. Here was 40 and 50 comparison, and then it goes to 50 and 60 comparison, 50 and 60, and now it goes to 60 and 70 comparison, 60 and 70 comparison, right? Now it goes to the next outer loop iteration set, that is 1. So now what happens is we have this particular list which is already sorted. Now it goes through this particular comparison, and at the end of this iteration set, it gets to know that okay, there is no swapping that was being done, and hence it exits out of this loop and it returns the value of the sorted list out, right? Because in the second iteration set itself, we are declaring the list has been sorted. Otherwise, we would need to go through 1, 2, 3, 4, 5, 6. At the 6 iteration sets we would have to go, after which we would have been able to declare as a list being sorted if we did not have made use of this particular was swapped flag. Friends, please try to go through this algorithm on paper once again and try to implement it without looking at the solution first. And then if you need any help, please let me know in the comment, or as well, you can also look into the sample implementation or the implementation of this particular algorithm that I have made. It is available in the GitHub, and the link of the GitHub is there in the video description. I hope this was useful to you. Thank you very much for your patient listening.